climate change, we're anticipating more variability in the amount of water and how it arrives. Less consistent, moderate rainfall. Surface water, groundwater, managing them effectively is critical to the sustainability of our agricultural sector, but also as a society, we have to balance the needs of industry with the needs of our people.
Although the phenomenon of climate change is daunting, there are opportunities, and I find that the Source Project provides an opportunity where people can actually find alternative sources of water. And as the UN keeps saying over and over, the climate change crisis is a water crisis. And so if we can find alternative sources of water to use, not just in PEI, but in islands globally, I feel that this project will be a success.
Prince Edward Island, or PEI, is Canada's smallest but most densely populated province. The fractured sandstone that underlies the entire island is highly permeable, and it stores and transmits large volumes of groundwater. These groundwater bodies, or aquifers, are so productive that PEI is 100% reliant on them for its drinking water. Agricultural fields make up over 40% of PEI's land area. Groundwater is critical for irrigation, making it an extremely valuable resource for the province. Most groundwater monitoring and management activities on PEI focus on onshore aquifers, that is, aquifers under dry land. In contrast, the Source Project, an international research consortium, is investigating the potential for offshore freshwater aquifers under the Gulf of St. Lawrence. Offshore fresh groundwater has been discovered in many places around the globe, but this phenomenon needs further study. How does fresh water persist under a salty ocean? Thousands of years ago, during the last glaciation, the Laurentide Ice Sheet covered this area, and all of the water temporarily stored as ice resulted in lower sea levels. As a result, continental shelf regions and what is now known as the Gulf of St. Lawrence were dry land. This allowed infiltrating fresh rainwater, snow, and ice melt to recharge the aquifers, similar to how onshore aquifers are naturally sustained today. As the last glacial period ended and the sea levels rose, these freshwater aquifers were eventually covered by a sediment seal in seawater, making them offshore aquifers. The Source Project is focused on mapping and monitoring offshore groundwater systems in the Gulf of St. Lawrence north of PEI to investigate where and if offshore fresh groundwater resources are present, their potential connectivity with onshore aquifers, and whether they can be sustainably managed to benefit island communities.
There's always this conflict between water users on PEI. So homeowners drinking groundwater, so their little domestic wells, versus the industry we call big potato that needs the water for their businesses. And so over time, there is growing concern about water availability on PEI.
So the good thing about underground water sources is that it's preserved. It's not something that is contaminated yet, and it's also seen as the new kind of water source.
What are the impacts socially? What are the indigenous communities' values when it comes to water? What are the fishers and farmers in the primary sector concerned about when it comes to water? What about the residents of the coastal zone? As our communities grow in the coastal zone, will we have enough water?
There's evidence that there's potential fresh water seeping from the seabed. So our goal is to really see whether there's any evidence of it influencing the biology that's living there. Clearly, if there's a source of fresh water coming out of the seafloor, that will affect the biology, which are marine organisms living at the seabed.
Our main objective is to understand how different habitats and different environmental conditions affect the biology. So in this case, we were looking at the potential of groundwater discharge in the marine environment. So obviously in the marine environment, we would expect salty water, but then if there's an input of fresh water, that changes things, and so we might see different species inhabiting these areas.
We have a camera system that has a downward-looking video camera. It's mounted on a small frame that we can lower to the seabed. It has lights attached to it. Obviously, we're working in about 50 to 60 meters of water, so it's relatively dark down there. So we can turn the lights on, we get a live feed at the surface. We can basically drift with the camera hanging off the side of the vessel. We keep it about half a meter off the seabed, and that will record video footage as the camera moves over the seafloor.
I use mainly an ADCP, which stands for Acoustic Doppler Current Profiler. It can determine how fast the water is moving, and to a certain degree, the direction it's also moving in. Most of the time, the ocean really only gets mixed from above, so it really only is affected by wind and the sun and things like that. But submarine groundwater discharge is sort of that in reverse.
We are just using a physical property, that is the electrical resistivity, to see if the rocks that we have offshore Prince Edward Island are saturated with fresh water or salt water. And the way that we do this is just looking at the behavior of the electromagnetic fields. If you have a rock that is completely saturated with fresh water, it will behave in a way different if you have the same rock but completely saturated with seawater.
After we got the data from the survey, we know the conductivity underground, so that we know like the interface of the salt water and the groundwater, the fresh water. So we know what's happening under there, how the water changes, whether the salty water intrudes to the groundwater.
So, for example, the last point.
The geophysical data can't tell you how to manage that groundwater or what will happen if you pump it. What we're hoping to do in the model is show what happens if you pump onshore aquifers to the offshore aquifers and vice versa. Because there's lots of things that could be a concern. It could lower water levels. It could create salinization or saltwater intrusion. It could create issues with subsidence, which is basically the land surface dropping over time because you're over pumping an area. The idea is that in the past, when the sea stands were lower, what's now submerged by ocean used to be open to the atmosphere, so available for fresh groundwater recharge. And so there is fresh groundwater under there. The question is, how long can it stay fresh?
My motivation to do this is really to add to our understanding of how seafloor ecosystems function, what drives those spatial patterns, and that information can then help to inform management of marine ecosystems in a sustainable way.
We never know what's going to happen when we do field work. It's usually very fun and interesting, but it also, we're at the mercy of weather and mechanical failures. Yes, it's September and sometimes it's windy in PI.
The most rewarding is the interdisciplinary nature of the project. We're going to have to sit down and try to talk together and try to see together what the big picture is and get out of our sort of smaller world.
Is a hydrogeologist.
Yes.
Yeah,
Jimmy.
Yeah, Jimmy John.
When my grandchildren and their children and their children would be able to say, hey, we can go to that bubbling spring over there like Grammy showed us, and we can drink that water, we can use it as our medicine. Or we can go to that river over there and fish out of that river and have nice fish. Or we can go to that brook or that stream. My wish is that it would become purified again, that it would become our healer again, that we can have that purification again. That's my biggest wish. That would be my dream.